See if this question helps you understand hybridization for the MCAT, and comment what other topics you'd like to see covered. In the molecule C2H4, which of the following best describes the orbitals involved in the CH bonds? Here's the molecule described, and to understand hybridization, we need to think about the valence electrons of the atoms involved when they're not bonded. Let's first look at carbon, whose valence electrons are 2s2 and 2p2, and that's the orbital diagram for carbon's valence electrons. If carbon were to form 4 bonds like what we see here, what the diagram to the left fails to explain is how these 4 bonds that carbon forms are equal in terms of energy. And the reason it can't explain the equal energy is because there are 2 electrons for each one of those bonds, which means we would need 4 orbitals for those electrons to fit in, and we do not have 4 orbitals of equal energy. So then what happens is the 3 2p orbitals and the 1 s orbital combine to make 4 sp3 orbitals. And those orbitals are what the electrons in those bonds occupy, and that explains why all the bonds are equal energy. When we look at the molecule here, when carbon has a double bond, we see 3 bonds of equal energy and 1 bond that's of a different energy than those other 3. Now we need a different hybridization theory to explain this one. What happens is instead of all 3 p orbitals hybridizing with the s orbital, 2 of them hybridize with the s orbital, and those come together to form 3 sp2 orbitals. And then we have 1 leftover p orbital. So the electrons in the blue highlighted bonds, those occupy the sp2 orbitals, and then the electrons in the other bond occupy the leftover p orbital. And the bonds that occupy the leftover p orbital are called pi bonds. The electrons in the hybridized orbitals are called sigma bonds. From the perspective of hydrogen, it's a lot easier to explain its single bond because it only needs 1 orbital for the electrons in that bond to fill, which it uses its 1s orbital. So the orbitals for all the atoms will overlap, and then the electrons in that bond occupy both of those overlapped orbitals. All of that together means that the CH bond is formed by overlapping the hydrogen s orbital with the carbon sp2 orbital.